Exercise 107, frequency histograms and polygons. A frequency histogram, that's the histogram there, and this is the polygon, which looks like a line graph. Okay, they graph quantitative data, and including data that is grouped into class intervals. So quantitative data, not categorical data. Okay. Just two examples here. Notice with a frequency histogram here, we're just graphing the number of phones owned per household. We can see that there are no households with 0 phones, and that there are 3 households with 3 phones. There are no gaps between the columns, and that there is a half column gap at the start, and that the numbers are centered underneath each column. So we'll put that the scores, they're called the scores, are centered under each column. Okay, that's really important. Okay, and half column gap there. And here is a line graph. The polygon. Often the polygon can be drawn on top, but this is a polygon just on its own. So notice that for one, we've got one phone. The frequency of one phone is 1, but on this polygon, it would appear like this. So the polygon can actually also be drawn on top of the histogram, and it starts half a column width away, and it goes like that. Okay, so you can have the polygon drawn on top. Remember, the frequency polygon joins the top centers of each column, and often you'll see it drawn with the histogram, but I've just drawn the polygon there on top of the histogram as well. And the polygon can be drawn by joining the midpoints of the tops of the columns, as I said here on the histogram. And it must start and end on the horizontal axis. So it starts here and it finishes there, half a column gap away. For example, the number 6 would have been there, showing that the frequency for number 6 is 0, and the frequency for 0 is also 0. Okay. All right. Frequency histogram and polygons, they are useful, again, as I said, quantitative data. You can also create a histogram and polygon for data grouped into class intervals. We'll look at that one on the next page. Also for showing the shape of a set of data. Okay, we can see that 4 is the most common, that it's sort of clustered around here. Okay, shows the shape of a set of data and how the scores are spread out. Okay, the strengths, it is really easy to read that data as opposed to having the data just as numbers. Okay, it shows differences and patterns quite clearly, as I was saying before. You can graph a large amount of data this way, and it shows how the scores are spread out. So it shows the spread of the scores. Weakness, it does take a while to draw. Okay, question 5, just an example here. Here are the ages of the employees at Burger Haven. This is quantitative discrete data because they are whole numbers. Okay, organize the data into a frequency table using classes of 15 to 19, etc., 20 to 24. Notice if you count 15, 16, 17, 18, 19, there are 5 numbers in there. 20, 21, 22, 23, 24, that's 5 numbers as well. So you must have equal sizes of all the classes. So the next one would be 25 through to 29. Look, what you can do, 19 take away 15 is 4, but if you want to include both numbers, you have to add 1. Okay, so as long as the difference between them is 4, but you still have 5 numbers in each class, this would be 30 to 34. This would be 35 to 39. This would be 40 to 44, and this would be 45 to 49. Okay, I think the highest number there is 49 in the data. Okay, then you have to class center, work out your class center, and the way you do that is that you add the 2 numbers together. So over here, I'll just do an example here, 15 plus 19. Please get a total before you divide by 2. So 15 plus 19 divided by 2, class center is 17. And the next one, 20 plus 24, get a total, and then divide it by 2, and you get 22. Well, it's pretty obvious this is going to be 27, this is going to be 32, 37, 42, and 47. Okay? But please be careful that, make sure that your number is halfway between, you know, the two extremities of the class. Then you have to do your tally. I'm going to let you just do that, but we've got 18, 19, 18. So 18, 19, 18 would all go in there, etc. So if you can just continue that, 17, 20, 20, 24, 15 would be here. Every fifth tally, you put a line across. 24 and 19, 24 and 19, that's the first row of 10 scores. Okay, if you can continue that, and I'll just turn the video back on when I'm done. Completed. You all know how to do this, just each of these is 5, that's 16, this would be 20, 4, 5, 1, 2 and 2. The other thing you want to make sure is that these all add up to the 50. You've got 50 bits of data up there, just making sure it adds up to 50. We've got 20 and 20, that's 40, 45, and these are 5, so that does add up to 50. And now drawing the frequency, the question, sorry, up here as well, how many people work at Burgerhaven? That's 50. Okay, and a frequency histogram and polygon, and then to draw that and then to comment on the shape of the data. Now, in the frequency histogram and polygon, you will use class centers for the middle of your data. Now, we've got to go from, well, 15 to roughly 50. So, oh, sorry about that. Frequency is 20. Remember, frequency goes along this vertical axis, so frequency is along there. Okay, and highest is 20. 5, 6, 7, 8, 9, 10, 11, 12, 13. And it will fit if we go up by 1. So we'll start 0 down here, and I'll just put every second. 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. So that's fine along there. And we've just got to decide, we've got how many classes. We've got 1, 2, 3, 4, 5, 6, 7 classes. And we can either make them, we'll have to decide how many columns, how many columns wide each one will be. So I think we either go 2 or 4 wide. But we'd have to make sure we can fit them all. I think we'll just make them 2 wide because we won't have enough room at the end if we make them 4 wide. So the first height is 16 for the class 15 to 19. So as long as we leave half a column gap at the beginning, 16 is our height. Should really be doing this in pencil. Now, actually I'll just do this in another colour. I'll do it in green or something. One minute, maybe blue. 16 of the first one. The next height is 20. Now write in the class centers a bit later. Okay, just get these columns done first. Make sure that you can see those. Okay. All right, now the next column is 4 and then 5 and then 1, 2 and 2. I'm just going to keep going. So we've got 4, then we've got 5. And I'll just pause the video and keep going. Half column gap at the beginning. This we can either, so we want the ages of our employees. So we can just put here that it's 15 to 19 in this group. Look, sometimes you can do class centre as well and just write class centres 17. But I'm going to put the actual ages, 20 to 24. We've got 25 to 29, etc. 30 to 34. That is in the centre. So it marks the centre of each column. I think I'd 35 to 39. 40 to 44 and 45 to 49. So that's our histogram. Notice half a column gap width at the beginning. And the polygon is just to join the top centers of each column, but also to start here on the vertical, on the horizontal axis. So just joining the top centers of each column here. And this one would go from You can put little dots there as well so that you know where the top centers are as well. Okay, on each of your points we're going, and then we finish half a column gap at the end away from the last column as well. So we join these two here. I don't know if you can really see that very well. And then down there, so it's highlighting that so you can see it. So your histogram are the columns and your polygon is the straight line graph, okay? And comment on the shape of the data. It does seem that our bigger columns here are at the beginning of the data, so it seems to be skewed, and we'll do more on this later, that it's skewed towards the lower ages, or it's clustered. You can even put that it's clustered. Yeah, it's clustered around the lower ages of 15 through to 24 really, or it's skewed towards the lower ages. In other words, it's skewed to the left. This again is question 8, and it is continuous data, sorry, it's numerical data, but it's not counted like in question 5, ages of employees. This is continuous data, so it's the height in centimetres. So for example, this 168 may have been 167.9. This 182 could have been 182.4, or it could have been, 181.6 or 181.5, for example. But the thing is, when you get to the borders of 165, take that back for a minute. Looking here at the class intervals, it's saying from 160 through to less than 165, and it's saying 165 through to less than 170. So this 165 must have been at least 165 or higher. Okay, because we can see here that 165 is on the border of the class. So it looks like when they're recording 165 here, for example, that it is 165 or higher. Whereas if they're recording it as 164, it would not be 165 yet. Okay, so I don't think these are rounded as how we normally round. Okay, now that might seem a bit confusing. So we are using these class intervals from 160 through to less than 165 and 165 through to 170. Okay, reason it's different, notice this finishes on 165 and so does this, but the table before with the numerical discrete data just goes 15 to 19 and then 20 to 24, and 24, from 24 it then jumps to 25, so there is no same end and beginning of class. It's because this data has been counted, okay, whereas this data is continuous, it's not discrete like the data in question 5. Okay, so this will be just less than 165, but this is 165 and higher. Okay, so again, class centre, you have to add the two numbers together. Don't worry that it doesn't include 165, you still do it the same. 160 plus 165 divided by 2. Make sure you add them together first before you divide by 2, and we get 162.5. And just do another one, 165 plus 170 divided by 2. Make sure that you add them together first, get a total, and then divide by 2, 167.5. I suppose you can see the pattern there. This next one would be 170 through to less than 175. This would be 175 through to less than 180. Then we've got 180 through to less than 185. And 185 through to less than 190. So this would be 172.5, 177.5, 182.5, 187.5. Then you can do your tally. Just be careful with your 165s and your 170s, etc., that they go into the correct category. So we've got 168 would be here, 182, 187, 185 would go in the bottom one, okay, not in the less than 185. 178 would be here, 176, 174 would be here, 163 and 164. Then we have 165 is in the bottom one here, not in the top one. 189 would be here. 185 would be in the bottom one. 165 is here. 162, 173, 164, 173, 178. Okay, now I'm going to pause and complete it. I suppose there's only one row left. I'll just keep going. 172, 186 is our fifth one there. 189, 175, 176, 180, 170, 168, and 165 is this one as well. Let's see how many scores we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 threes are 27. We need to have 27 frequencies, so that's 4. That's 5, 5, 5, 2 and 6. We've got 15, 19, 20, 21, and 6 is 27. So that all adds up. We have to draw a frequency polygon for the data. 1 minute there. Draw a frequency polygon for the data. Our highest frequency is 6. So we'll either go up by 2s or 3s. I think we can go up by 3. So 1, 2, 3, 4, 5, 6. That's the frequency. Okay. And just for the polygon, we will put the class centers in the middle of the... Okay, so there are 1, 2, 3, 4, 5, 6. What would be columns if I was to draw a histogram? So if I've decided, I think there's about 28 little squares. If I make each column 4 wide, if it was a histogram, for example, the width of the column would be 4 wide, 1, 2, 3, 4, and I would have to leave half a column gap at the beginning, which means that the first class center would be there 4 units away. So this first class center is 162.5. So this again is the heights in centimeters, and I'm just putting the class centers. Okay, so the next one, so let's say if I was to draw the histogram, I'm just going to do the first one in pencil. I'm not supposed to draw the histogram. It would go up to 4, all right? Just practicing. That would be the histogram. And then another one, the next one would be 5 high, for example. And we've got 1, 2, 3, 4 wide. So let's say that would be the histogram and how it would look. I'm not going to complete it because we're not meant to draw the histogram. But the top of the first column would be there. So with class center 162.5, frequency is 4, then we've got 5, 5, 5, 2 and 6. The next one, class center is, if it was 4 wide, it would be there 167.5 halfway through. So I'm 4 from the beginning there, another 4, another 1, 2, 3, 4 would be my next class center, 172.5, 1, 2, 3, 4, that's 177.5, 1, 2, 3, 4, that's 182.5, and 1, 2, 3, 4, that's 187.5. They're my class centers. So I don't have to draw the histogram, but if I did, that's what it would look like. I'm just going to draw the polygon. So remember, we start in the bottom corner. And if that was the histogram, it is half a column gap from the beginning. Then we've got frequency of 4. Then we've got a frequency of 5 for class center 167.5. Then we've got a frequency again of 5 for 172.5. Another frequency of 5. Whoops. For 177.5. So if we're just looking here. Then we've got a frequency of 2 for 182.5. And we've got a frequency of 6 for this last one. That's 5. That's 6 there. Okay, now we just join these. So remember, this is just the polygon. So down there. And then here too. These are all joined across the top here. And then we're down to 2. And then we're up to 6. Okay, and then we have to come back down, remember, to where the next one would have been, which is 1, 2, 3, 4 away. That's going to be my last one down here. back down. So remember, polygons start on the horizontal axis and finish on the horizontal axis. It wouldn't be right just to graph them like that. It's not a line graph, okay? It's different to the line graph we did in a previous exercise. Histograms and polygons start and finish on the horizontal axis, okay? So is that 1, 2, 3, 4? Yep. Okay, so it finishes there, it starts there. And if the the polygons start and finish on the horizontal axis, and if we did have the histogram, it would have looked, you know, like this, all right? But we didn't have to draw the histogram. Now it says, what is the modal class? Well, that's the class with the highest mode. The modal class is 185 through to less than 190. What is the lowest class interval? Well, this is the lowest class interval. It's not 180 to 185 to less than 185. That's the class interval with the lowest frequency. That's not what they're asking. What is the lowest class interval? This is the lowest class interval of 160 through to less than 165. And which class is the least common? That is the class with the lowest frequency, which is what I was just talking about before, which is this one, which is 180 through to less than 185. Okay, that's the end of this lesson for histogram and polygons. Okay, I just make sure you label your axes, and as I said, start and finish on the horizontal axis. And if there was a polygon, if there was a histogram, the polygons would be in the top centers, would join the top centers of each column. Columns, where the columns would be